Hello Android developers, we all have been using Android Studio to create Android projects. We just go on it, tap the create project button, and it starts getting the full project structure for us with multiple files and folders, and we can just go and write our Kotlin files, change some libraries, and that's it. We can build the app and run it, right? Pretty simple, right? But it's not, because there's one big problem in this. The problem with it is abstraction of knowledge. Android Studio does so much automatically for you that you end up knowing just how to code, how to write Kotlin code and compose code, and when it comes to you changing configuration, you have to change libraries version, you have to change more deeply about how Gradle works. Then there is when you struggle. You always rely on code snippets, AI to change the configuration of your project, and that's the problem. You don't know why an Android project is called an Android project, because there's a lot of tools behind the scenes which are working together to make it an Android project, and you should learn it. The second problem is you can write UI code, but you don't know how your Kotlin code is converted to an APK, how your full Android project with so much in it that you already don't know so many of things, you don't know how those things are converted to an APK, because this is not a simple process. It consists of so many processes, so many steps in between, which are relying on different tools, and you should know it. So I'm going to teach you that in this video. So let's start on the computer screen. Now we are in an empty folder which is manual Android, and we will be creating full Android project template which Android Studio automatically creates manually. So firstly, before we do that, you would have a question, which is, if we want to create an Android project from scratch, which files should we create first? What is the first and foremost thing we should do? And that takes us to a concept that you have to learn first, which is Gradle. Because Gradle is the big part of Android development. It is in all the processes. You say when you have to download libraries, when you have to update some dependencies, you have to build the Android project to make APK, all in all these processes Gradle is involved. So firstly, the first thing we should initialize is the Gradle. Let's talk more about Gradle and learn about it more. So for understanding Gradle, just think about it as Gradle is nothing but an independent program which doesn't know anything about Android. Yes, it knows nothing about Android in itself. It is just a program which does just one thing, which is executing tasks. Yes, Gradle is nothing but it is a tasks executor. It just executes tasks. And what are tasks? A list of tasks like you have in life, like you have to do this task today and multiple lists. So that's it. Gradle just has a list of tasks and it just executes those tasks. And what the tasks it can be, it can be compiling code, the Kotlin code you wrote, compiling it to bytecode, then that bytecode to some other format like dex, if you know. So Git is nothing but a system in which you give it task and it executes those, and it has the sense of tasks. Like it knows, like if it has a list of tasks, task B should be executed after task A completes, because task B depends on task A to be completed fully before it runs. So it knows all of that and it can do it properly well. So that's pretty much it. Let's talk about how do we initialize Gradle in a empty project. So let's go. Now we are in anti-gravity. Open the manual Android folder in it, and if you want a video on anti-gravity using it efficiently, tell me in comments. Back to the topic. The thing is, now we are going to install Gradle for the use, okay? But there's a catch. We are not going to download Gradle as any other application we do, like WhatsApp, Chrome, or any game, but we are going to delegate this work to some other programs. So we are going to download some other files which will download Gradle for us. We are not going to download it on our own. We are going to tell those files to download it for us. And there's one thing that you should know about Gradle. See, this folder you can see on your user's local C, which is .gradle. It is the main directory of Gradle, and if you go to this wrapper and dist folder, you will find multiple Gradle version here. And yeah, this is multiple Gradles downloaded, not one. Like you download, if you are were to download Chrome, different versions from 2020 to 2025. So you can say, assume that these are individual Gradles with different versions. These are complete Gradle system with everything it has, but all of them are different versions. Why we have downloaded same software but different versions? There's one reason. Every single Android project uses a specific Gradle version. If you are using some Android project which has a specific Gradle version, it would have all the dependencies, I mean some dependencies which are related to it. So what I mean is, if you have a specific Gradle version like 8.5, you would have to use a specific AGP version and along with that Kotlin version. So if you use latest Gradle version, you can use latest AGP version and latest other dependencies as well. So as different projects have different Gradle version, we can't have a universal Gradle installed at some point and all projects use it. No, because every project needs different. Okay, that's why we have multiple Gradle versions in it, and each project uses what it has. If project uses Gradle 9.4.1, it will reference to this file. If it uses this version, it will reference to this file. So every project will work seamlessly without any crash. So that's why we have different end version, and in this project we will be mostly using this version, the 9.4.1, the latest. Okay, so let me tell you more. Now we are going to download two files, which is gradle.bat and gradle.wrapper.properties. I mean, sorry, gradle.wrapper.jar. These two files. These two files are responsible for downloading the actual Gradle from the internet, from the actual Gradle repository. And why we do it? Let me tell you. Suppose you have this list of Gradle versions, different Gradle versions, and you want Gradle 9.4.1 for your project. Okay, and you have to download it. But what if I tell you, you have to actually do this, you have to code this, that firstly your code will check that do you have Gradle 9.4.1 on this location in your PC, and if it does not, then it has to download it and store it here, and that is a zip file. And when that zip file is downloaded, it checks if this zip file is already extracted or not, and if it is, then it uses it, and if it's not, then it extracts, then use it. And if this is what you have to code, then what you will say, you can't, bro, you are Android developer. So that's why people have made this easy for you. That is why we have Gradle these two files. What they do is they go and check, they ask you that which version of Gradle you want, you tell it, then it goes to the internet, downloads it, and before downloading it checks if you have this version of Gradle in this location of your PC. If yes, then it skips downloading and checks if this file is extracted or not. If it's zip, then it extracts it. If it's extracted, then directly use it. If it's not, then extracts and then use it. So this is the code which is written in both of those files. That's why we need those. And one more thing, that those two files require one more file, the file in which you tell it the link from where to download it, which version to download, and they just download it. They just look for that file. Yeah, they look for a specific file with a specific name. So you are going to create a file with that specific name, and they read it and then downloads it and does the only thing. And let me write the file name, which is gradle wrapper dot properties. This is the file they look for, and in this file you write something like distribution, you write something like this. Okay, so I have changed the file a little bit, and let me tell you what this file is for. So when we run this gradle.bat file for downloading the Gradle and using it, it asks the JVM to create a process for this file for executing its code, and what its code tells the JVM is to open this file in which is written where to download the Gradle if it's not there, and if it's already downloaded, where are the Gradle files. That's what it tells. So this specific code tells where is the Gradle file, And this specific code tells if we have to install it, where to install the zip file, because when we download the Gradle, it's in zip format, and where to extract it. So that's it. So distribution base equals to Gradle user home. It's an environment variable, so it resolves to this address, this specific address in your PC. You would have, if you have Gradle, you would have this folder. So it resolves to this. So we have main Gradle folder here. Okay, then comes the where actual Gradle files resides, which is wrapper dist folder. You can see we have this. We have all the Gradles here. Which specific version we want to use? This is 9.4.1. Is it there? Yes, 9.4.1 is there. So it doesn't have to download it. But if it had to download it because it's not there, then it would go to this link, download it at the location where zip store base is, which is this same exact path. So the zip will be downloaded in the same exact this folder and also extracted in this folder, and the zip file is not here, it's deleted. So that's it. That's pretty much it. So that's it. If it is already there, then it will use it directly. So let's start running the gradle.bat file and see what happens. Gradle.bat. Now you can see that the build was actually successful very fast. And if you were to use it in your project, maybe it will take time, because if you don't have this exact Gradle version, then it can take time. So that's it. That's why it didn't take, because it was already there. It referenced to this. So that's pretty much it. Let's move to the next topic. So as we have set up this and the build was successful, so we know that Gradle is working fine. Now it's time to write other files. So when we will actually run the Gradle, it will look for other files in order to build it. So Gradle has hard-coded in it that it needs to look at file named settings.gradle.kts. It will search for it. When it finds it, it will starts reading it. And what that file tells the Gradle. When Gradle is reading your project, it looks for file called build.gradle.kts, in which you define all the plugins and libraries used in this project. And when it sees those lines and sees the libraries and plugins, it needs to download those from somewhere. And you define from where to download these plugins and libraries in the settings.gradle file, and also that file also defines how many modules you have in the app. So that's the work of it. So let's create it. Now I'm going to paste the code directly and save it. This block of code, plugin management with repositories, means if you encounter a plugin code in which you have given a library name with version, download those libraries from these repositories. It will go to this repository or Maven Center or this and find that specific library with name you have given and version, and downloads it and stores it in Gradle cache. And when it sees implementation code, it will download it from these. This means that this is root level, like any dependency required in any module of this project will use this code, will use this dependency thing. So any module which wants a library will use this code and these set of repositories only. And if any module requires any plugin, then it will use this exact code as well. It cannot write its own dependency resolution management and use the repositories defined there. Let me create the full files, all the files, and I will come back to you and tell you all the files I have created and why I have created it. So that would be more easy and faster for you, and I will be able to teach you more better and faster. Now the whole project is done and all files are created. Now let's understand each and every file one by one, understand how the project files converted into an APK. So the first step, the first thing that runs is this gradle.bat file. This runs and asks for JVM to start executing this file, the gradle wrapper.jar. This consists of some classes which tells how to download the Gradle. So this tells the JVM to run this file, and the JVM starts running this code, and what this code tells it is to go and read this file, and in this file it reads all these variables and the values and knows how to download and install Gradle in your PC. It reads it, it resolves it, you know it how it does. I have already explained this step right in detail. Now moving to the second. For the next set of steps, I would be using this file list so I don't miss any step. So let's move to the next one, which is this file, which is not a simple thing. It is a 𝗕𝗵 process. So when this gradle.bat is running, ran this file, this is running in a process, a 𝗕𝗵 process, and this file reads this thing and one more thing, which is gradle.properties. And this thing reads this, but it has only to do the work with this key and value pair. These two are ignored. I will tell you what these are, but it only has to do with this key value pair. And what it does is, this is the one which only downloads the Gradle and it initializes the Gradle, because Gradle is the actual process. It is called Gradle daemon, and just like your Windows updates are running in background silently, WhatsApp is syncing messages, they are all running background tasks, they are all running background processes which are executing something, and you are getting the new messages and all. Just like that, this, when it's running, it downloads it, and when it's downloaded, it opens it and initializes it. Its work is also that. And while initialization, it has the privilege to tell it how much RAM should that new process of daemon should take, because that daemon, which is the daemon, it is able, it has so many tools, dependency tools, it has plugin tools, it has a lot of different tools, okay, that allows it to execute tasks, resolve dependencies and all. And that daemon is created with this file. And when this file starts and reads this, it says, do we have a Gradle daemon already or we don't have? And if we have one, does it has the same RAM? If it has the same RAM, if it has the same Gradle version and the same RAM allocated and one or more two fields, then it uses that, it reuses that Gradle daemon. And if something doesn't match, then it doesn't. Maybe it will check, does it has used AndroidX this value true and this equals to official. If it has, then it uses that, or it creates a new one if it can't use, because there is some distinction between them, so it can't use it. And when at birth of the daemon process, it allocates us 2 GB RAM only, because there's a lot of thing in Android, so we should give it more RAM. So that's the thing with this file. So this reads this and the actual daemon starts the process. Okay, so after the daemon has actually initialized, you see Gradle, which is the actual Gradle, it starts, it reads the libs.version. Before that, it reads the settings.gradle.kts, which we created here. See, it reads that, it knows that if I see a plugin, then where to download it from. If I see a library, where to download it from. Can every module have its own dependency resolution management? No, it says no, it will give error if they have. It says, okay, we have this module and this is the root project name. Okay, so as soon as it reads this, it goes to the app. Okay, so it reads it and it says, I have an app module, learns where to download plugins and libraries from, and then Gradle reads the libs.versions.toml. You know that is here, libs.versions.toml. If you don't know, we have a cleaner way of writing versions and plugins versions and libraries. This is file called libs.versions.toml, in which you write all the global uh, versions of all the libraries and plugins you are using in your app. Let's skip it. And it reads it and loads the centralized version catalog. Okay, so it reads it, so it knows, okay, we have these, it can resolve it. And whenever it sees libs.version like this definition, it knows, okay, this is the library I have to download and this is the version. It knows how to read the libs version 2ml. Okay, so now Gradle reads root build.gradle files after settings and version, reading that, it goes and reads the build.gradle.kts of the root file. What this file tells it? It tells it we have to download AGP. What is AGP? AGP is Android Gradle plugin. It is a plugin which attaches itself to Gradle and teaches it how to build Android app. That's where actual thing starts. That's where Gradle knows how to build Android apps. It doesn't know how to build Android app yet, but when this line is hit, when this file is opened by Gradle and this particular line is read by it, and it knows, as it's read the libs version file before, it knows, like, it's saying that I have to download this thing of this version, right? It downloads it and it knows, okay, I have to download it. Once it's downloaded, the AGP gets attached to the Gradle itself, and now the thing starts. But here in root file, that is not happening. It's just downloading it, installing it somewhere in the cache, and that's it. We are not enabling AGP here because we have applied false. It means it's downloaded, installed, but currently not enabled. And same goes to this is a compose compiler, which gets attached to the Kotlin compiler and converts compose annotations like added composable to code, which Kotlin compiler can transform. We will talk about it. Sure. So now it reads this, then let's see what happens. It reads this download AGP and compiler plugin compose compiler and download, but don't activate yet. Okay, then Gradle reads the app build. Now it goes to the app and reads the app build.gradle version. Now when it sees this, now here we don't have a false, and here's 2. Now this AGP gets attached to the Gradle and it tells it all the tasks of what building an Android requires. It gives it all list of tasks. See, plugin activates AGP's takeover. Now from here the Android Gradle plugin takes over. Now we are adding extension functions to the normal Gradle plugin. Now when Gradle hit this line, it knows everything. When it didn't hit it, when it was here, it didn't know what this block of code is, what is Android, what is namespace, what is this Android full block, what are all these things. It didn't know about it. But as soon as the Gradle reaches this line, the AGP attaches itself to it, tells it what this means, what does Android means, what does namespace mean, what all these code we have written, all this text, what it means. It gives it all the tasks. Like, it gives it tasks, what task to perform to build an APK. Like, firstly it had some copy, delete or some tasks, but after it hit this line, it gets list of 100 plus tasks which help in building the Android app, Android APK. That's it, the power of AGP. And AGP is not something small, but it consists of many things, many tools inside it. The app tool, which converts resources file to arcs, and it contains DA tool, the RA tool for converting Kotlin code to Dex code, right? It has all those things. So I will tell you about this compose compiler. If you want even detail about every single plugin and all, then you can tell me. But let me go to the thing, and at the end I will talk about little about all these plugins. So just know that this compose plugin attaches itself to Kotlin plugin, which is in this AGP, which comes in built in this. And whenever the Gradle sees Kotlin files, the compose compiler plugin sends it to compose compiler, which converts it to Kotlin code. The annotations like composable and all are converted to Kotlin code, and then the Kotlin compiler executes it. And that's the thing. Okay, so you know that after running this, it knows the AGP is running and it's attached it with it. It knows how to read all this code, and all this code, you know it, right? You would know it already. So let's move to another thing. After reading the app build Gradle file, it reads the local.properties. Now, why it reads gradle.properties and local.properties? Let's see. In local.properties, we are pointing to Android SDK. AGP needs to know where your Android SDK is, the software development kit, which consists of many tools which are adb.exe emulator, right? It has android.jar, which consists of all the classes stubs, like uh, all the classes which reference. Suppose you are using a code and you are referencing to some service of Android, then how do Kotlin and Android Studio will resolve it? It needs to know where that code is, because if we are using something like app component activity, right, then it needs to know where that is. It needs to know if it has text, then it needs to know where that text composable code is living. And same like that, if you are using Android specific code in your file, then it needs to know where is it. And the Gradle reads this local properties. It gets there. Here is it, the Android SDK, in which there's classes and libraries in which the actual code resides. And whenever you point to it, that service, it goes to this location and knows, okay, this is what you are referenced to. Now let's talk about gradle.properties. Let me uh, tell you what gradle.properties. Now ditch this. This is just linting some syntax stuff special. It just improves some syntax according to good practices. The main line is this. Let's understand this. In older days of Android, there was a problem like you make an app and it's on running on Android 7. Now Android 8 comes, you add a feature in your app which is specifically on Android 8, and when the user on Android 7 updates it, it crashes because it's using some feature which is on the mobile itself, on Android 8 operating system itself. It's not on the APK. It's expecting is it to be on the phone itself, but on Android 7 mobile it is not there, so it crashes. So that's why Google built a support library called android.support library. But which it does was, there was some code which can be separate from Android operating system, that can be added in apps itself. So what happened after that, apps started to contain extra code, but that code made it safe that that new UI or that new component works on Android 8 and 7 as well, and more lower versions, because now the code which the feature it was using was built with the app. But now this is limited to somewhat classes or some libraries, like it can't be like a low level thing could be added in the app itself. No, some of the thing like UI or some things can be added. So that library was called Android or support library. But as it grow so much, it became a mess in naming conventions. So just and Google changed the full name, and the code remained the same but structure was changed. So that's Android support library was then called AndroidX library. So this is it. If you are, and when we do it, we are telling the AGP that we are using the new structure of support libraries, not the older structure. And if we are using older libraries and AndroidX libraries both, then it will crash and say it will crash. So either use AndroidX structure or use the older, but who is gonna use older structure, right? So we keep it true, and yeah, we have to tell it true that we are using the new AndroidX structure, not the older Android.support. So that's the thing it does. Yeah, but that increase the size of the app, because now we are bundling extra code with the app, not just the code of the app, right? But now Mincify does it, because what we use we take, not what we don't use. So that's the thing. Okay, if you don't understand it, you can comment, okay, because I can't fully explain it here in deep. The BW is already so long. Okay, then Android now reads the build.gradle and part. Okay, now it reads this part. Let's see. Okay, it reads this part and sees SDK version, compile, compose features, all these things. If you want to know about all this code, then you can tell me, because this video is going to be long. Then dependency resolved, see you have written this. It says okay, we have this, then it goes to libs it, okay, we have to download this. And as I already said, that settings.gradle tells like if you want to download library use. And as I already said, that settings.gradle tells like if you want to download library, you can download it from here. So when it sees This line of code, it goes, because it's a library, it goes to settings.gradle. It knows, okay, I can download it from both, any of them. So it goes and searches in these two, and it found it. If it finds it, then downloads it and installs it, and then we can point to the library code. That's pretty much simple, right? That's pretty much simple. Let's see what happens. Okay, every library and these plugins are also downloaded from them, right? And the task graph build agp calculates the execution order. Okay, then that's pretty much it. That's it. So for very quick gradle.bat runs, jvm runs, it tells to run this gradle wrapper.jar. It runs and downloads or opens the existing gradle, and then it reads this file. Okay, it reads this file, it knows, okay, these are the versions. Okay, it builds it so it can point to it later. It reads this file, it reads this file and downloads them. Okay, then it reads this code, then it reads, like, that it reads this. There's a sequence. I will give it in the comment section or description, or if I'm posting on LinkedIn, I will give it in the post itself. Okay, you can see the sequence. There is a sequence in it. And let me tell you one thing, one more important thing: you can't be like anything, any file, anywhere. There's a sequence. If you may mess it up, Gradle will mess you up. So there's proper sequence. Gradle should be a Gradle folder in which there will be a wrapper folder in which there will be Gradle wrapper.jar, exactly like this. Okay, this is downloaded. Gradle wrapper.properties, exact same name, exactly same. Libs.version in wrapper, exactly this location, nowhere else. It will crash. Exactly this location. Build file, this build.kts of root folder should be in the root folder. This gradle.properties should be in the root folder. This b should be in the root folder. This should be in root folder. The build.gradle.kts of app module should be in app module root folder. In src we should have and manifest, the manifest, you all know, right? Manifest is in here. The And inside java you should have the same com example folder that you have defined here. Same inside java you should have that. Okay, this is it. You do it and you write this. That's it. Okay, and after that's pretty much it. Then you just go and build gradle.bat assemble debug. Okay, and then it runs it, and you can run the app. Oh, it ran or not? Okay, it's running. It's running. Let's go. I think we should uh cover the uh other part in the next part, which is how Gradle now converts, whenever we run the build run button, read button, what happens and how it converts to APK. I think we should do it in other video. Sorry for telling it, we will cover it in this video, but it's so long that we will be covering it in next video. So that's it. I will show you the snippet of running the running app in. Okay, bye.